Hey everyone, in today's video we're going to check out my free stereo console that I got on Facebook Marketplace. I had been watching this thing for a week or two, and one day I noticed it went from $150 to free. So I sent them a message. I said, how broken is it, and has anybody else signed up to get it? They said that it mostly works and that 2 people had committed to come check it out the next day. So I said, what if I showed up right now? And she said, then it's yours. So I showed up in this thing and the rest is history. I haven't even plugged this thing in to test it out yet. So let's take a quick tour and then let's see if it works or not. So I've had 2 consoles on my channel. This is the 3rd one, and those 2 I could move around by myself. This one, absolutely not. It is an absolute tank. We've got nice hardware on the front here. Those do not open. I've got these 2 handles. They're just not attached right now. And this looks like it's a pretty high-end Magnavox. We've got speakers right there, speakers right there, and on the back, it's in really good condition. It looks like all of the screws are present on the back cover. The top of it is in pretty good condition, certainly not perfect, and certainly not helped by the fact that this was basically a workbench the entire time this thing was being worked on. So let's take a look inside the boring end. This is where you would keep your vinyl records. It came with a few little accessories. We've got some casters, but only 2 of them for some reason. There's those handles I was talking about. One of them is missing half of its hardware. Then we got some stylus accessories and whatnot here. Then we got this switch for speakers. You can do internal both or external. Wow. Wrapping up over here and coming to the exciting side, we see that this is the Magnavox Astrosonic. So you can be Astro with your Sonic and have squelch sends. This thing does not say solid state, but I'm pretty sure it is, but we'll definitely find out when we take off the back cover. We see that our off switch is broken. In fact, that was one piece that was in that collection of parts over there. We're gonna need to turn that on with a pair of needle nose pliers or something. We've got FM stereo, which is awesome. The tuning meter turns really nice. And then our record player, this is what I was told was having some issues. Hopefully we can bring this thing back. And here's that power cord. What do you say we plug this thing in and see what happens? If you'd like to know the story of this thing, watch until the end of the video and I'll tell it from the seller's point of view. Oh, we're moving. It's already turned on. And I hear some AC hum. I wasn't expecting this to happen. We've got loudness here. If I turn that up, nothing happens. Oh, it looks like we've got action out of our tuning meter. I don't see a stereo light. We're on stereo FM. Uh-oh. Okay, that might be why we're having trouble. This one is also broken. I'm gonna get some needle nose pliers here. Okay, so that feels like phono right there because it won't move anymore. That feels like aux. And then that might be stereo FM, because now we have movement out of there. It's really unusual to me that I can't get anything out of this. Like, I've got some AC hum, but in terms of the tuners, I've got absolutely nothing. I cannot get any sound out of this thing. So let's go over to phono. Let's try out the record player. Let's bring back a classic, Accordion Hits, and see if we get any sound out of this record player. So we'll turn this on. And I hear the AC hum. And if I bring this over, does it work? Almost. It does work. So believe it or not, the last time I had this record in a video, they gave me a copyright strike. And I think that this record player is turning too slow. Let's see if auto return works. Oh, it does. It's trying. And there you go. So we've got no sound out of the tuner at all, a record player that plays at the wrong speed, and very, very dirty controls that really need a cleaning. Let's get this thing flipped around and pull the back cover. Taking a look inside here, this is all solid state. This is a solid state amplifier, and just based off of here, it might be direct coupled. I don't know if it's capacitor coupled like I would have expected. And then over here we've got the tuner preamplifier section. Behind that is the record player. We've got the horn pushing out front and the woofer on the side. Over here we've got a more detailed wiring diagram. And of course we've got some hitchhikers from years past. That one over there is in pretty good shape. I wonder how old he is. This right here is a little suspicious. I don't know what that's doing there, and it certainly does not look like it was added by the factory. There was a hole cut in the back of the cover just so this switch could be here, and one end of this switch goes to nothing. Yeah, see? So what did this used to do? What is the idea of having this back here? And these thick black boards here, those are clearly for acoustics, so the music gets more to the front. So I've been poking around in here, I've just been kind of perplexed by the fact that if I switch to AM, like I can get the signal to max out. So clearly our AM tuner is working. I tried doing some jiggling of controls. If I jiggle the bass control, I can get sound again. The squelch sense is very, very dirty. So now that we have sound, I'm curious, do we get FM? If I turn it up all the way, we get something. Maybe you can hear that. It's super quiet. What does Timbrad do? I don't know what Timbrad does. So given the fact that I can make a lot of sound out of this thing just by messing with controls, I think this whole thing just needs to be completely taken apart and serviced generally, and we might get a lot more performance out of this thing once that's done. Any visually bad components are replaced, etc. Then we can start doing some true troubleshooting of this thing. So I'm gonna start gutting the power amp and the tuner preamp assembly. We'll get them on a bench and check them out. Also, I think I'm starting to notice what this weird switch might have been for. Maybe the internal-external speaker switch on the amp was malfunctioning. And I think somebody installed this in its place because this is just going to where the speaker outputs are. It's also not installed very well. You can see this orange wire just has a piece of electrical tape on it. Somebody did this a long time ago and they didn't even solder. So we're gonna have to fix that. Okay, I don't know what that's all about. Maybe we'll find out once we revert it back to normal. In fact, let's just get that done right now while it's on my mind. So for this, I'm just gonna strip a new section and then I'm gonna wrap it around this part of the terminal and then just flat out solder it. Yep, that's gonna be pretty good. Let's just double check that that still works after that mod. Yep, we've got sound out of both speakers after messing with the controls quite a bit. So how about we continue with the original plan of taking this thing apart. First, let's go ahead and clean this thing out. It's kind of dusty and gross inside, and I wanna do myself a little favor. Let's start by getting this main power amp module out. So there's a few connections we've got here. We've got all of our ground things for the speakers. We have what they're calling channel 1 and what they're calling channel 2. So those are separated. This right here is our output from our preamplifier. So I can come out, and then this here is the main connector for all the power, all the switches. Hiding under here is a power light, which I don't think works. And we'll get this strain relief after, but I think we can start by undoing these screws here. And there's our power amplifier module. And of course the strain relief. That's what it looks like underneath. Looks like some pretty old style capacitors under there. To get our tuner preamplifier module out, we'll need to start by removing all knobs up here so that this whole thing can kind of slide right out. And they've left me a note right here. It states, "To service man." That's me, I guess. Disconnect tuning meter leads before removing radio chassis from cabinet. So I think what they're referring to is stuff up here that I might need to take care of. It's going to be difficult to get that on camera, but I will make sure all that stuff gets disconnected properly. I'll go ahead and disconnect the harness here as well, and then we can just leave this in the cabinet. This is power connector for the record player. There we go. The antenna connected down there, so we'll keep that with us. At the very top up here is the leads for the record player or turntable. Looks like we've got 2 hex bolts back there. The one, I can't get it. And then there's 2 up here on the side. And then it's little Phillips, so they look nice. Very long. And I'll start getting these 2 and we'll see what happens once we get this thing loose. Is it gonna wanna just fall right out violently? You know, I should probably have the one still threaded down there. Yeah, I put both lower screws back in, so hopefully that won't let anything bad happen here. And there you can see it. See how all of this is moving, including this, but the tuner meter is not? That's what they're warning me of. The tuning meter is not going to come out with this. And now as I loosen these 2 screws, this should just kind of come right out. And there it is. Next, let's see if we can get this record player out of here. And I think we start that from the top. First, let's lift off the platter. I'm pretty sure that comes off. Yep, just like that. And we've got a screw here. A screw here. And a screw here. And does it lift out? Okay, there's a little clip underneath that I had to undo. And I may have broken something. I'm not certain yet. Looks like we've got some what used to be foam. Not doing us too much good anymore there, huh? Alright, so we've got all 3 of them out. This here is the tuner preamplifier assembly. See all our controls right up front there. Here's our power amplifier. And then here is the turntable. This is the one I'm least looking forward to, so I think we should start right here and give the power amplifier module a service. Hold on. Don't even think about it. You don't want to mess with this. And of course we got this one over here. Trying to stay out of his way, or he's trying to stay out of her way, right? Alright, here is the amplifier module. And this is the first one I want to take a look at because it's going to be the easiest. We've got 2 inline caps down here, these 2 big guys up here, and then just this printed circuit board where I see 8 capacitors. I'll bet you each one of them is bad because this is from the mid-1960s. In fact, it says right here, August of 1966. So that means that this thing is 60 years old. And we want to replace all of the capacitors. I'm just going to give it a quick wipe down for my sanity. Should power wash it, but not today. So in this section in our testing, we didn't really have any issues with it. So what I'm going to be focusing on is just component replacement of known bad things like these electrolytic capacitors. I'll also check these carbon comp resistors to make sure they're within spec, because these brown resistors with this kind of squared off edge here, these have a tendency to drift in value. So we want to make sure we catch any that are not right. So I'll go ahead and start on the circuit board here. I'll be able to get these out with my desoldering gun. Oh wow, would you look at that. We've got component designations on the bottom of the circuit board. That's incredible. So that means there's no guesswork for me looking here, then looking over here, looking here, trying to figure out which pins go to which component. I can just take them right out. So there's those 4 right there. I'll go and desolder all of those. So we're flipped over, and as we pull these out, we're going to make sure the component orientations are correct with the installation. So our positive lead is right here, and that's what the board says. This is supposed to be a 50 microfarad 3 volt capacitor. That's a very low voltage, but let's give it a little test with the ESR 70. So 93 microfarad is double what that should be. This is not a good capacitor. Its friend over here, again, board is marked correctly. Same deal. Not good. We don't like that. How are these 250 microfarad caps? Let's take a look at these guys. 398 versus 250. And last but not least, yeah, not what we want in here. So let's get some replacements installed. So for replacements, we're going to go a little bit overkill. For the 250 10 volt, we're going to do a 330 25. Now, I would do a 220 25 if I had that, but I don't. So I'm going to do a 330 25 because 220 is closer to 250, and 250 is one of those values that was used in the older times, like this 1960s era gear. Similar to 50, like we don't have 50 microfarad capacitors anymore, we have 47 microfarad capacitors. I do not have 3 volt capacitors. I would never stock something like that for what I do. So I have a 50 volt 47 microfarad. And is that overkill? You bet. But it is what it is. Let's flip over and get those soldered. Of course, I gotta bend the leads a little bit. Tell you what, folks, it is rare that I get double help in an evening. Thank you, you two. Now we're going to come back at it with the Hakko, get those other 4 capacitors we saw sitting around. One of them fell out, and there it is. And the silkscreen on the bottom is marked correctly for it. So our negative ends are facing each other on this side. Since this one fell out, it means it's eager to be tested. Let's see what we've got going here. It's supposed to be 500, and we get 879. No thank you. I'm not even going to test the other 3. I know what's going to happen. We've got some brand new 470 microfarad 25 volt capacitors. So I'll rip off these 4 right here. Let's just give a test for one of these new ones. I want to compare the ESR value. We had, what, 0.39 for that other one? ESR of a brand new cap is 0.09 ohms. So, yeah, these caps, all of them in here are just very bad. We don't want them. Get out of here. Oh, this one has leaking electrolyte on the bottom of it. Let's test this one and see what happens. Open circuit, low capacitance. Try that again. Yeah, so this one is completely failed. Nothing left of it because all of its juice is leaked out. I've just been painfully reminded that my tip is too hot for what I'm doing right now. I had my tip set to 800F for another job I was working on, and well, I really should have double checked before I started this, or thought to set my soldering temperature. See, right in there, not only did I do a terrible job soldering that joint, I also lifted the trace. And that might be difficult to see, especially when I can't work my camera. But I've just cooled down the tip, so I'm going to try and push that down and fill that in. And now it doesn't look like I lifted the trace. even though I did. So even though I really don't think it's that big of a deal, if we want to add some, see there, you may have just seen that kind of snap back. What I can do is I can just bring this lead over to here on that solder joint right there. And again, this is not proper, this is sloppy, but it's something. We'll just marry these two together, and now we have a more reliable connection on this. And as I do a little wiggle test on my others, I don't see any lifted traces, just this one. So this one's just gonna get snipped right here. Heck, I could probably just leave it with how they left it from the factory on that side. But now that's one less thing to worry about. And now we go from the future all the way back over to the past over here with some point-to-point wiring. That's where we've got our, looks like a bridge rectifier. We got 4 diodes right here. We got 2 large capacitors here, but then in the chassis underneath were those 2 orange ones. So it's kind of funny seeing a Nichicon capacitor from the 60s. That's a 300 micro 35 volt. Here's a 330 50 volt from the future, or now. Look how much smaller it is. I might not even have enough lead to connect this thing in the factory configuration. Looks like this one in the back here is attached at the chassis and this terminal, so let's do some desoldering. It's also attached right here at this pin. I'll probably leave this here because I think I'm gonna need it. I'm gonna have to cut this at the lead. Come in with the iron and pull this lead back like so. Heat up the joint, get her moving around in there, and look at that. Now we can just bend that back with pliers and move it straight out. My wire cutters are just closest to me. There we go. And like I said, I'm gonna cut pretty close to the lead here, just so I have this extra and I don't have to mess with that solder joint right there. How does this old thing test? 300 micro? Now it's 490 micro, 0.08 ESR. That's not too bad. How's this new one test? Yeah, I'd rather use this capacitor. Yeah, interesting how this is the positive end of the capacitor. We're gonna have to be certain we do that correctly. Can we reach? Not really. Here's what we're gonna do, folks. This pin right here is grounded to the chassis, and that's where this capacitor was grounded to. So we're just going to put this guy back on this pin here, how we found it, and then we're going to take our capacitor, we're going to solder it this way, this way, because the positive end was over here. We'll just wrap our leads around. And now for this part, I am actually going to want my tip to be at that 800 degrees. Now let's direct our attention to this one. This one here, its positive end also being grounded to the chassis. So for this one, I'm not even going to desolder it. I'm just gonna snip it right there. Then I'll pull it out of this thing. And then for the capacitor, again, we'll just find one of the grounded terminals on the terminal strip here. That came out pretty easy. So I just desoldered these guys so that the hole opens up, and then I can just slide this right in, just like I did on the other side. However, since we could potentially short out on that diode there, let's just put some little tiny pieces of heat shrink tubing on here, and that will insulate the leads from that diode, which we don't want being shorted on something. Alright, these two feel kind of wrong putting a positive terminal on ground, but whatever. That's how I found it. Now we gotta take care of these two. These are each 1500 microfarad 35 volt DC. So how am I gonna do that? Do I have some 15 hundos? I don't have anything, so I'll have to order something. What? You were just yelling at me. What do you want? You want scratches? There you go. Big scratches. What about you? You want scratches? Yeah. Alright, so there it is. I found some 1500 microfarad caps on Mauser, and we will replace these two. But I'm actually going to mount these underneath. I'm not going to have them sticking out like these two are, and you'll see why in a second. This is not the clearest thing in the world, but cap number one is under these wires. It mounts right to the chassis on its negative leg, and then its one positive leg is this red wire right here that I'm pulling out, which goes right there. Well, the chassis is attached to this one, and there's the red wire, so we'll probably just go like this. Let's just snip that wire off. Pull that through. So we'll start right here. Let's remove this solder. Oh, interesting little detail here. This wire kind of sneaks around, so we actually need to keep that wire there, partially. You see that? These two are shorted together, so I'm actually going to have to snip this wire around here. And we'll remove this piece of insulation and just kind of wrap that back around. And for the negative leg, which we just soldered here, we'll have to undo that. I'm going to flip this around real quick to just address that rivet I was talking about. Right there. We just got to get some solder on that so we have a true connection. My desoldering tool can actually do a pretty good job at this. If I turn it up all the way on the bottom here, I can maybe get in here and get some true heat on this thing. I'm sorry folks, that's a tough one to get, but there she be. I'd like to think that that got hot enough and we'll have a better connection right there. And there's what a factory one looks like. Obviously they had a nicer iron than I did. Anyways, let's get that cap in there. The positive is going to go here, and the negative is going to go there. Alright, this one's going to be a little trickier. So our positive is going to go right to the chassis here. We won't want this wire anymore. Try and remove all this stuff here. And come in like this and kind of pinch that over. Let's go ahead and get that taken care of. So that's secure, and now we can just kind of hook this onto the negative body of the cap, because these three on the outside, they're all common. Okay, that should do it right there. We'll see if this blows up when I put it back in, I guess. That marks the completion of this. I checked a lot of these resistors off camera. They all seemed fine to me. Probably could have checked these a little more closely, but just didn't feel like pulling a leg for each one. The stakes are pretty low with this thing. I'm not too worried about it. Alright, now we've got the preamplifier and tuner module. This is going to need a lot of cleaning. Let's just start right up front. We can already see how dusty this thing is. We don't want that, so just Windex should be just fine. Oh, actually, maybe it's not fine. Oh, this is felt. Wow, I feel like an idiot. Yeah, how do you clean that? Good thing I didn't spray it directly. This is actually turning out kind of nice, not gonna lie. Yeah, I'm actually quite happy with that. I do have some replacement lamps for this thing, so let's go ahead and just install those while I'm thinking about it. I guess we'll use this spare LED for the front indicator lamp. Let's come around back and take a look at our tuning cap here. Inside of there is all the fins. We'll just spray that with a contact cleaner and work the cap a little bit. I don't see any electrolytic caps in there, so we're just gonna put this back and that'll be dried out by the time we're ready to test it. We're gonna flip over and come under here and we will see all the switches right here. Now we certainly recall in the beginning of the video how awful all of this was. So this is all gonna need a really deep cleaning. So when stuff needs a really deep cleaning, short of disassembly, we want to start with this stuff. It's the same as this stuff. In some videos I call it WD-40 just to mess with people. And it does get some people confused and riled up and it's really funny. So we're going to use some WD-40 on these controls here. And I have with me a knob with a zip tie on the back so it keeps it together. So probably have to do that to all the surviving and non-surviving knobs to keep them working. So anyways, but that was a selector of some sort, so is this one. Now that I think of it, these might be our tone controls. Moving down here, this feels like a volume pot. Certainly a potentiometer and not a switch. This one down here I know for a fact is our main power and selector switch. I'll try and angle this correctly for you and show some light. Look at all that black tarnish on that wafer right there. So I think even just that little spray took, yeah, see? It rinsed it right off. So this is good stuff here. Then we got one more down below, but that's not the last one. The last one is hiding. Well, last two rather. Now if I flip this around, we'll see two more of them. That squelch sense one was one of these two. They're right there and right there. Actually, I think I'll flip the thing over, that'll make my life a little easier. Alright, now that we've done that, I'm going to flip back over again. We're going to go over everything with the actual deoxit now, since we've flushed and dissolved in some cases some of that really bad stuff that we don't want. I've got a broken can right here. I think this is a good day to try to use up this broken can. Hopefully I don't just make a giant mess. I knocked this off my bench one day and well, yep, see, it's just coming out of there. See, anything I can get to come out of here is a big win. And I'm not going to hold back on using it. Normally you don't use this much D5, right? But this can is broken, so I can use all I want. Sometimes just spraying is not enough. You do need to do some work with mechanical removal using a foam swab or something. You see, even with that Q-tip, I just went in with nothing on it and got all that tarnish out on it. Alright, now we're going to use the F5 on the potentiometers instead of the switches. Alright, now that that's all cleaned up, let's move on to some capacitor replacement. The first one I want to tackle is right here on this control. It's that little blue guy right there. So let's go get that removed. That'll be a 5 microfarad 25 volt. We can replace that with a 4.7 25 volt pretty easily. In fact, we'll do a 4.7 50 volt. I think I'll start by getting the negative on here. Yeah, you can see my little bend right here. That's gonna keep this out of ground's way. Yeah, look how crappy that tests. Not good. Let's go down under. There's only a few down here. Is this okay? Yeah, that's fine. Yeah, remember these guys from the power amp? Got 2 more of them right in here. So let's see what we can do about that. Both have the positive on the ground. So again, interesting. Wonder what that little thing is. I don't know what that is. Better be careful with it though. So here's how I'm going to do this one. I'm going to tie them together at the positive because they were both going to the ground, and then I'm going to run this wire onto here. We'll solder that just a little bit. Nice. I'll cut this to length later. Not bad, not bad. Flipping around here, I do notice one buried deep in there. You can see it, the black with the red cap. Let's see if we can get the tester on that and see what's going on, because if it's good, I'm leaving it alone, because that looks like a pain to get to. We got 13, but pretty high ESR. A replacement would have about 1/4 of the ESR. Yeah, I should do it. I should do it, but I don't wanna. Maybe if I can solder this wire scrap on there, I'll do it. Okay, so here's what I just pulled off. You see that cap right there? I just soldered this wire to that lead of the cap, so I can take out the original cap at that one and then cut right here. And now, would you look at that? That's a decent connection. Now I can just take that and run it to my new cap, this little guy right here. I didn't want to do it, but I powered through and I did it. Okay, that is all I see down here. Let's move up top. Based on the looks of it, I'm assuming this is the preamplifier board. We've got 1, 2, 3, 4 electrolytic caps per side. I'm going to go ahead and replace all 8 of those. And then this board looks like it has something to do with our tuner. We have 1, 2, 3, 4 of them. So let's get them out and get them replaced. Alright, I think that's pretty much it for the preamplifier tuner assembly. Now it's time to get the turntable. Alright, I'll be honest with you guys. I really don't like these. I think they're terrible. I think that anything that's not running on a quartz-locked motor is just not even worth bothering with. And this is definitely one of those things. There is The motor just spins at the speed you set it at, I guess. Looks like this bearing is actually really nice. I noticed it was playing too slowly, so we'll see what that's all about. But like, I hate how light these tone arms are. Like, I don't like these. So let's just go underneath and take a look, I guess. We can secure that. Oh, yep, that shows how much I know. And I really should have known better. Jeez. I really should have known better than to do that. Okay. As far as I'm concerned, this thing seemed to be starting and returning just fine. Of course, there's a lot of different points that need to be greased and whatnot, but everything feels okay for the most part. In terms of the motor speed, I don't know how to adjust it. I just see these two wires going right off to here, so is there an adjustment? I don't know. The only thing that could potentially be a problem is these guys right here. Alright, so I'm looking at this thing and I'm kind of looking at how this idler wheel system works here. First we gotta look at this thing. This is our on-off auto switch and our speed selection. So I want to show you what happens when we choose different speeds on here. We gotta turn off first, but look at this. As we go to a higher speed, the wheel drops down. As we go to a lower speed, the wheel drops up. Now what's that going to do? Well, when we're turned on, we are against this. This is the motor spindle. And this small machine diameter is going to be 16. Next step down is 33, next step down is 45, and then the next one at the bottom is 78. So I've got her set to 78. Look at what's happening here. So, you know, that's going to spin just fine. We got 78. But then I go up to 45. And you can see, well, actually, I'm still kind of hitting the 78, but if I pick this up, well, now I'm hitting the 45. But if I go even to 16 and I push this in, I'm hitting the 33. So it would seem to me that I need to lift out this idler wheel by undoing this circlip, which wasn't too bad. And this comes out. There should be like a washer or something right here so we can lift this up. The rubber is still fairly soft and sticky on this, so I don't know what all we need to do. This one I'm probably just going to leave it alone. That one sits at the 45. This is for driving the auto return. So I've got the wheel chucked up in a hand drill here, and I'm just going to kind of real lightly on some sandpaper. That should be enough to kind of renew it. Give it a nice fresh edge for grabbing onto the platter and whatnot. And then I just found this random washer. Let's just throw that in there, see if that helps us with what we're trying to do. That actually raises it pretty nicely. I'll try and put the clip back on. So if I turn on and I look, I'm set to 16. Let's go to 33. That's much closer than it was, that's for sure. Down to 45 or 78. Yeah, it's a lot better than it was. So maybe we'll try that out. And I would really like to test this up here. I thought I wouldn't be able to do that, but then I realized we have this harness that was in the cabinet, and that was what kind of linked everything together. So I can take the power right here, power amp. We'll just kind of position that under device under test, make sure that's all off. Then I can come over here and we'll just plug this stuff right back in, and the record player plugs it into the back. And then this harness will just go from the power amp. And then we gotta plug the record player back in. We'll plug it into the one that says PH for phono. So I've got the whole console kind of set up here. I believe we're turned off, but let's start on dim bulb. Okay, we are turned off. And I think this is the power switch, maybe? Yep, it is. No shorts. I don't think anything's going to explode. It would have exploded by now. So one thing that's a little concerning to me right there is if I turn this off and then I turn it back on again. See, that's 0 volts. We got some pretty decent DC offset. And I don't know how to adjust that on this thing. Could it be because we're on dim bulb? No, in fact, being on the line voltage makes it even worse. All right, folks, good news. This thing is working. I've got radio, FM, and AM.
A budgeting app that helps you create a simple plan for your money. Every dollar.
And all you gotta do is give them all of your money. Anyways, I did not have working radio before. And that's because I missed something. If you look right up in there, you'll see 3 new capacitors that I completely missed when I was doing the recap earlier. One of those capacitors had 32 ohms ESR, and another one of them, well, that's not going to work too well, is it? Getting at least those 2 capacitors out of this thing got the radio completely working again. I got lucky with that one. I didn't have to do any true troubleshooting. I just shotgun replaced the capacitors, which is an okay thing to do with stuff this old. I mean, I've had so many capacitors in this thing with way high ESR, so shotgunning them can actually be an okay thing if you're okay with not understanding what it is you did that fixed everything. Had I not missed those, I wouldn't have known why this radio is never working. So though it seems like the preamplifier and tuner are working just fine at this point, there do remain a few issues. One of them is this turntable. If I go right here, and we take a listen, it's working, but I know, and maybe some of you watching with perfect pitch know, this thing is going too slow. And I need to figure out how to adjust the speed on this turntable motor. And then back here in the power stage, you probably won't be able to hear, but I'm going to take my microphone. I've got it at the test speaker. There's a pretty decent AC hum. Then I want to show you something more concerning to me. Take a look at the DC voltage at the speaker terminals on this thing. This one's got 333 millivolts DC offset, and this one has negative 224 millivolts DC offset. That's a fairly unusual thing to see with these console power amplifiers because normally they're capacitor coupled, but if you look at the schematic and check out the power supply, the amp board uses transformers actually. It's really interesting. I'm not sure how that circuit works, but I would like to fix the DC offset problem by adding an adjustment or something, and I'd also really like to get rid of that AC hum. I think that might be the first thing I try to do. Maybe I should have done this earlier when I was doing the recap, but you see those diodes there? Those might not be working quite the way they used to back in the 60s, so I'm going to replace those with a modern diode that's better than those. These are 1N1692 diodes apparently, or at least they're supposed to be according to the schematic. We're going to replace them with 1N4004s. Alright, I've got it on dim bulb. Let's see if I did that right. Looks like I may have so far. Alright, something would have exploded by now. Let's check the speakers. Moment of truth. There's still some hum there, but I can't tell if it's better than it was or not. Nah, I think it's the same. I guess that kind of rules that out. Still a problem though. Remember that one time I looked at all these resistors and said, I don't feel like checking those, I'm just gonna leave it alone. Yeah, those were good times. See? Red, red, brown right there. That's supposed to be a 220 ohm resistor. And we got 359. And I paid all this money for the Sam's PhotoFax schematic and printed it off, and this isn't even right. None of this matches what's actually on this board. So I really am just going off of what I see, and I have to do this at component level and see what's out of spec and what isn't. So this one right here, that's going to need replacement. We're going to need a new 220. So I guess I'll just mark that one as needing to be replaced. Let's keep going here. This one's supposed to be 220. I'll have to replace that one too. The silver band means 10%, so that means we can be up to 22 in either direction. So that means 198 would be in spec on the other end of that. In spec. This one's supposed to be 270. We're in spec. 270 again, in spec. 220, out of spec. 220, barely in spec. I'm gonna call it out of spec. 220 in spec, out of spec. And this 270 here, in spec. I never showed you all the very first one, but it is in spec. That's a 270. See, I was reluctant going into this to kind of, do everything correctly, per se. And now that I'm down the rabbit hole and I want to make a good video for you all, here we are. Caps are much easier, but these carbon comms resistors, they might as well be like caps in a way, So we got 5 220 ohm resistors that need replacement. We'll get these 5 out. We'll just double check that what I have here is actually a 220 ohm resistor. And it is. Dead on. These just came out of some Amazon pack that I picked up for like 15 bucks for like a million resistors. So it's always worth checking. I'll try to get the height of these things set nicely to match kind of what the original ones had, so that it looks nice. And I do that by kind of looking over here and bending the leads under here once I see the height I'm looking for. So yeah, as a reminder, we are doing this because we're trying to track down that crazy DC offset happening at the speakers. I believe that that's probably due to just bad components at this point. Like, I think that these resistors are pretty heavily responsible for setting a lot of what's going on in here. Since there's no adjustments, you have to rely on your components being exact and good to get the measurements you need, or the settings you need. So I'm going to go through and get the rest of these resistors checked, and I'll let you know what I find that's way out of spec. Alright folks, I have just replaced all of the resistors that were out of spec, and we have some different results. You may recall both the channels had like about 300 millivolts DC offset at the speaker terminals. Well, check out what we've got here. This is at one of the channels. We only have 160 millivolts now. And then if I switch the probe to the other channel, now I've only got 113. That's great and all, but I'd still like it to be 0 like the schematic suggests it should be. And I didn't really know how to do that because my schematic does not match what I actually have here. All my component designations are different. Things are slightly off, but I noticed one thing. So this board is basically left and right channels, more or less. And you can see this one and this one got replaced on both channels. So that got me thinking, what if the value of this resistor determines the DC offset? So I got curious. I wondered, what if I connected a resistor in parallel to one of those resistors? So here's a 560 ohm resistor. This is a 220 ohm resistor, so that means we should get about like 150 when we connect it in parallel. Now watch what happens to that voltage when I complete this circuit, when we lower the resistance of that resistor. Look at that, we're a lot closer to 0. And then on the other channel, if I raise the resistance on this resistor, I get closer to 0. So after doing this trial and error, it looks like about 150 ohm resistor should do pretty well in that spot there. And then over here, I still need to figure out that value. I'll probably start with a 330 ohm and see what happens there. But yeah, I guess that's just accounting for drift and everything else over the 60 years this thing has been alive. So I'm going to swap these out and see if I can get 0 volts DC offset on each channel. Like I alluded to earlier, I think component matching is kind of important for this circuit to get it to work the way you want it to. And a lot of this stuff is drifted. We got 60-year-old germanium transistors in here, which are questionable in some circles. There's a reason they switched over to silicon from germanium. So I think I'm going to find the right values for these resistors, throw them in, and then I'll have my desired DC offset. All right, folks, I'm quite impressed. On the one channel, we have 3 millivolts, and on the other one, what is it? 9 millivolts. I like that a lot. I am very happy with that. The one side got a 150 ohm, the other side got a 330 ohm, and we're off to the races. Except we're not off to the races yet because there's still one more thing I want to address, which is that AC hum. Now, this thing's turned on. I'm going to switch it back to my speaker. I'll take my mic, put it in front of here, maybe you'll hear it. No one likes an AC hum. So I tried a few things, and what I came up with is if you just increase the capacitance of that one right there, the AC hum gets a lot quieter. So I will demonstrate that by putting this capacitor in parallel with the one that's already in there. So when I touch this right here, there's going to be a spark. But the AC hum kind of got cut in half because we doubled the capacitance there. So it's a lot quieter, a lot more livable. And I bought 10 of these things when I bought these replacements, so I might just double this thing up, put that in there in parallel, because I don't have anything that's about this size but more capacitance right now. I also took one of these things. This is out of, I think this is out of the Power Washed Pioneer SX750 actually. When you put this thing on there, it gets much quieter, but having a capacitor this big for this, probably not necessary or a good idea. Hey, you want to see some Electro Boom stuff? I don't know if you just heard that get louder, but this is a charged capacitor, and if we short it out like this, it does that. Kind of cool, huh? A little mini welder out of our capacitor. It's discharged now. Now we can hold it and it's safe. I guess I'll add a disclaimer. That was safe-ish, even though it wasn't, because this was only charged to about 30 volts because that's what that rail is. And 1500 microfarads is a bit, but not the most in the world. Like, if this guy here was charged all the way at 50 volts its capacity with 15,000 microfarads, I would not have done that. It'd probably turn these into a liquid. We like to have fun here. Alright, that might not look it, but it is in parallel. These two are in parallel. They're just connected at different points. The AC hum is quieter. I wish it was gone, but that's just kind of the design of this thing. It's not that great. One last thing on this power amp. First, it's kind of funny that I started this video saying, this is going to be the easiest. Yeah, turns out it's been the most problematic and difficult. There is one potentiometer on this thing, or sorry, trimmer. A little trimmer pot right there. The best I can tell, that is this thing right here. Balance. So why do we have a trimmer pot between two channels where it's kind of goes through a resistor and a capacitor, then goes right to the output, and is also kind of sort of quite close to the negative rail on both channels? Good question. I don't know, but I found out what happens when you turn that thing. So, you know, just imagine me doing this, turning this thing while I'm over here. And what I'm going to do is I'm going to focus in on the scope. So we've got the 1 kilohertz coming into both channels at the right amplitude that doesn't make it clip in the preamp. Ask me why I'm thinking about that. I had to turn it down. It was coming in too hot. If I turn up the volume here, we'll be able to see that clipping once it starts happening. See? So what I'm going to do is I'm going to go turn that potentiometer. Oh, would you look at that? I can get this thing so off kilter. Like, what the hell is this adjustment? What the hell is this design? I've never seen anything like this. Like, and this is assuming my balance pot is in the right spot. Like, I'm messing with the one on the power amplifier to do all of that. Now I'm gonna go over to my balance pot, you know? So like, with this design, like, that balance control on your power amplifier is only as good as how centered your balance potentiometer is and how well your balance potentiometer is working. Because you can see this potentiometer, like, normally on a properly working potentiometer, you can get these to balance out. They'll be like at their max output at the middle of the control. But you can see there's some overlap with this control. It's a very small amount of overlap. So I need to find that small overlap point. I think it's right about there. So now that I've set the balance on my preamp, I'll set the balance on my power amp. That's that right there. All right, so now let's try some power test. Let's bring it up. We see we get clipping early on the blue channel, and that's probably not good, but This video is too long now at this point, so I'm just gonna pretend that that's not happening, and I'm gonna go off the top up here, just for funsies. Oh, this is fun too. Look at that. The volume potentiometer has play in the yellow channel. This is me doing the volume potentiometer. If I go a little bit higher, see, like, I don't know. I've been kind of refraining from saying it. This 60s console stuff is just junk. It's not good. So let's call it 14 volts. Let's say this thing is putting out 14 volts. That's about 25 watts per channel, a little bit under it. So respectable. You know, the speakers on these things are pretty efficient. I think this will get quite loud once we're back in the cabinet. All right, let's go ahead and mess around with this thing here. So it looks like online I read that the motors in these have bearings that have grease that gets real nasty over time. Oh, and also I read that there's an adjustment for the height of this wheel, so maybe I can take that washer out of there and adjust it properly. Adjustment is done by turning this screw that you can't see. There's a little adjustment screw right here. You just turn this and it makes it go up and down. See it moving down and see it moving up when you tighten it. So let's take this snap ring out of here, see if we can get this to set correctly with this washer removed, because this is not supposed to be there technically. I did not realize we had an adjustment. Everybody loves snap rings, circlips. This is everybody's favorite thing. Okay, my speed is set at 33 RPM, so that means I need to be right about up there, but I'm not. I'm right about there. So let's see, can I get it up there? I'm at the far end of the adjustment, but I think I'm there now. I was also thinking about how this thing works, and the diameter of this wheel is actually going to determine how fast this platter moves, because, you know, this is one speed, and then the size of this wheel is going to determine how fast it turns the platter. So I don't know, we'll see if I messed that up. I think a bearing is going to fall out, but that just is what it is, because we got to come under here. Or the 45 thing is going to fall out. We got to take this motor off. Oh, look, more circlips, yay. So we've got two right here, and then there's one back there that you can't see. We'll just start getting them. Need my tweezers. There's a little ground strap right here, noise thing. Oop. Now this should lift out, maybe. Yes, they've just been in there for 60 years and they're not too enthusiastic about coming out. Oh, now what do we do with these wires? Ugh, gross. I need to figure out how to get these wires out, and I'm leaning toward trying to de-pin the connector here. Okay, got my red wire out, that's great, but my black wire is soldered directly to here, so I need to desolder. Okay, we'll need to put that back. But now, oh, why does this stand up now? Oh, it's because I have the arm. Now we can take out our motor. This one has our little ground cable on there, so I'll just paint that in Sharpie so we know that we're supposed to put the cable back on that side. I'll do a little line right there. I don't know what's going to happen. Alright, 1/4 inch fasteners. Alright, what's going to happen here? Ah, there we go. Well, that all looks fine in there. It looks like it's been balanced. Maybe I'll just spray it good with contact cleaner and make sure all the junk is out of there. I don't see bearings, I see bushings. I'll just spray the inside of here. Whoop. I don't really want to lose this orientation though, so I think I'll just leave that be. Clean off the rotor. This is the last of my can of CRC. And like I said, inside of here is a bushing. So looks like if I just stick this down here and try to clean up what's inside of there, nothing's coming out. If I just stick some machine oil down there, that should be okay. So clean this off a little bit. Clean this off. I'll take this stuff that I bought and just put a drop in there. I'll put 3 drops in. Why not? Set that back in. Then right here, same deal. 1, 2, 3-ish. Oh, that spins so nice. It might even spin better. Who knows? Okay, and then there's my Sharpie mark. Here's my other Sharpie mark, so that means this goes like this. And we can start putting our fasteners back in. That's a motor, I guess. Looks like some of my oil spilled out. I'll just wipe that down. Maybe we'll reapply once we have it in the unit here. All right, let's go back in. Alright, then we'll take this greasy bearing, which the grease still feels okay on this. That platter would not stop spinning, you know, so I'm not too worried about this grease. Now let's set this on here. I mean, look at that. So let's get this plugged in and see what happens. I'm willing to bet that this works exactly the same. Oh. Would you look at that? We've lost our mechanism that engages. How do we get that to work again? Oh, I found it. When you put this thing too high, this is supposed to be moving right now, but if I lower it, then it starts to work. And then it sits too low, which is just lovely. So we do need to put that washer back in. Wow. We'll put some lube right here, small amount. Put some on the shaft here. And wow, look at that. Shove that back on there carefully. And that moves again. So let's do a redo. Let's try this again. Okay. Does it turn on? Yes. Now it moves. Let's go to 33. Does it turn on? Yep. Looks like it plays a little faster. Alright. Let's give this a shot. Oh my gosh. That actually fixed it. It's at least a lot closer than it was. Wow. It's a lot closer now. I'm pretty happy with that. Does 45 work? Yep. 78 works? Oh yeah. That doesn't sound very right. How about 16? Yep. Get some vaporwave stuff going with this. I didn't think that was going to work, so I'm very pleasantly surprised. Oh, and how could I not? Let's do the auto return. Wah! And there you go. It works. So in conclusion, I bit off a lot more than I thought I was going to have to chew. So let's talk about all of them. Our preamplifier tuner section here. This thing had exceptionally dirty controls. We cleaned them quite well with contact cleaner and deoxit. The tuner was also not functional, and that was due to some failed capacitors in a section that I missed at first. It's right here. I showed it to you guys in the video earlier. Two of those capacitors were in such bad shape that was probably keeping the thing from working. One of them was just completely opened. So replacement of those three capacitors brought function back to our tuner. This power amplifier, I thought it was going to be easy, but it ended up being the most problematic. There were a few issues we ran into after the recap. Well, I mean, first of all, there were a lot of horrible capacitors on this thing. It needed a recap very badly. So even after that recap, there was a massive amount of DC offset on the speaker terminals, and I figured out that if I play with the value of some of these resistors in here, I could get that minimized. We had a filter capacitor that wasn't quite doing its job. I thought it might be the diodes. That wasn't it. Turns out just adding a little bit more capacitance to that rail solves a lot of the AC hum problems. I think that if this design were to be upgraded to silicon transistors, maybe we would get a little bit better performance out of this power amplifier, but what that would require is different biasing of these transistors. I would need to do a lot of playing around with resistors to make sure that we don't have too much bias going across those silicon transistors, having this thing run super hot, because the germanium transistors, they function differently than the silicon transistors. I think they need a smaller forward voltage or something. I haven't looked too deep into it. I didn't really want to get that deep into it in this video. So that would be a future upgrade thing for this, but you know, I don't really think it's terribly worth it. I think it's worth playing with the vacuum tube amplifiers that come out of these consoles, but all too often you see these solid state amplifiers and they're just not that great. There could be a much, much better power amplifier installed in this thing and be far more worth it, spending more time on that. But, you know, it's here. I got it working better. Then with this turntable here, I had very little faith in my ability to get this turntable working properly again. But after taking a look at it, I realized the height of the idler wheel for adjusting the speed was not correct, so we got that fixed. And then the cleaning of the motor, I really didn't think that would do much because it felt pretty good, but it turns out adding a little bit of oil to those bushings and cleaning them out and reassembling everything, maybe even cleaning with the contact cleaner the inside, the rotor and stator, that helped things quite a bit. So this thing is playing at a close enough speed for my ear. Maybe not some others, but I think it's pretty close at this point. So now it is time to finally bring this thing back to the cabinet and add some Bluetooth. There are a few very small things to do still, like this is our power light. This is going to shine out of the front of the console. It's got this little piece of cardboard on it and a burnt out lamp. So let's put this new LED in here. Stick our cardboard back over. Oh, maybe not. Yeah. I don't think we need it. I left the screw in here. I'll just stick this through there, and then we will re-secure it. Then over here, I loosened the speaker crossover board, and I tested these capacitors right here. They're rated at 8 microfarad. They each came in around 9.5, and they had good ESR. So I'm gonna leave these in the crossovers. I don't think replacing them will make much of a difference. If I had non-polarized, audio grade, whatever, 8 microfarad, I would do it, but I'm just going to leave these there. Let's work on setting this turntable back in here. Now the fasteners are a little bit interesting. One of them gave me some trouble. There's that. I think we just turn these till they're tight. For the turntable, you just tighten these 3 screws and it kind of pushes the springs back up and suddenly you're mounted and good to go. Next, let's get the preamp tuner module mounted in here. There were 2 screws that went through down here and then 2 more that went through up here, these guys. So I think I'll start with the 2 lower ones. But before I can even do that, I need to reconnect the tuning meter up here. And those leads are right here. And where do those plug in? I think they plug in right here. Looks like I'll be able to connect those in just a minute here. Yeah, I would describe this part as no fun. You're basically completely blind putting these this back one in, and nothing really wants to line up. It's not being terribly nice to you. All right, let's plug some stuff back in. First, let's do our turntable connector. That goes right there. Next, we'll do the turntable audio. That's gonna go way up there. Oh gosh, I can't read any of that. All right, so the one up top says PH, so that's where the phono is gonna go. And then the one on the bottom is gonna be for the power amp, but we're not quite there yet. FM antenna is just gonna connect right here. So we can go to the larger antenna that's actually on the console. There we go. This is the harness for the power amp, and that gets re-secured right here. At least I think it does. Let's try and get this power amp back in here now. All right, that's mounted. Plug the harness in. Re-secure the power cord. Yeah, they could have given you a little more wire, but they chose not to. Right here, these twisted wires, that's our power lamp, so we'll go put that back on here. This here looks like a ground connection for a speaker, so we'll put that on the G. This black wire here, probably also G. And then I don't remember which one, brown or orange, was channel 1 and 2. Oh, it says right here, the orange is channel 2. Oh, I got those mixed up. And last but not least, I can't forget to hook up that tuning meter. I think we're ready for a test. Well, if I messed something up, I suppose we'll get a tripped circuit breaker, right? We use the timbre switch to turn it on. Oh, would you look at that? It's working. Well, I had a feeling something wasn't going together correctly. If I try to tune this thing, look right there. Our meter or pointer is caught on something. So I need to figure out what the heck that is. All right, that wasn't so bad. Just had to adjust. I got caught on like some of the paper or whatever. But this thing is like crazy dirty. Let's do something about that. Since I'm in the garage, let's use some car stuff on it. Let's see if that does anything. Yep, that's pretty good. All right, now it's time for the best part. We're gonna get this thing Bluetooth. This is just a little module that you can buy on Amazon. I'll put an affiliate link in the description, so you can have one too if you're looking to add Bluetooth to something. It's really quite a simple module. It's just, you know, it picks up the Bluetooth with this thing, and then you can use an RCA cable to send it to wherever you like. And then it's also got this power adapter, 5 volt for USB. Guess what this thing has built right into it? It's got a power outlet on the side of the preamp. I don't know if I ever showed that in the video. Maybe some of you noticed it. We'll just give it the 3.5 to RCA, and then the 5 volt to USB adapter. Now how are we gonna do that in this thing? Well, my thought is we let it live inside of here and then drill a hole right down there. So here's the album side of the console. I think we can just have this live right in here, and that way you can access it and hit this button if you need to. Well, I guess I've got two options. I could kind of glue it to the side in here. Actually, I changed my mind. Here's looking from the back. That's where it's gonna sit, because you can run those wires right under the turntable here and it doesn't interfere with the workings of the turntable. You can have them come out through here, and then right up in here is where you can plug in the audio And then down under here, there's a power outlet like I was talking about for something else, some auxiliary thing. No holes, don't have to drill anything, and it can be super easily removed. All right, let's see if this is a switched or unswitched outlet. Looks like it is switched, which is what I want. Let's turn this back on. There we go. And let's set it to aux. Forget where we're set right now. Okay, let's hit the button and try to pair a new device. Okay, looks like we're paired. And let's go listen to everybody's favorite song. There it is. Everyone's favorite song. That's pretty cool. So now aux on here is Bluetooth. Now this thing, we would like to secure it a little bit, so I've got some command strips here. This is like the Velcro type, where if you put them like this, you can remove it if you want. So let's just stick them on here. And there. Completely removable if someone so chooses. One of the last things I'd like to do is get this switch cleaned, because this is the last stop for our speakers, so we can switch between external speakers if we wanted to, or both. And the way we're going to do that is we probably have to take this panel off so we can get access to that switch. And I'm hoping I can just clearly see those contacts in there and just spray it with some deoxit and call it good. Oh yeah, that's really easy. Yep, there should be right up there, pretty simple to get to. And the last thing I need to do before we can put the back on is I want to reinstall these guys. Now I only have one of these little decorative covers that goes right here. I tried finding another one on eBay and I just couldn't find one. So I guess I'll just put this on with, oh geez, I'm gonna need like tape or help from a friend or something. What do you say, folks? Let's take these 20 kajillion screws and put this cover back on. It would appear I'm missing one screw. And I'd rather have that screw be there than there. I don't have any good wood cleaner, so I just want to give this a quick wipe down with, believe me, this is just water. It's just water, folks. It's gonna be okay. Welcome to my beautiful Magnavox Astrosonic console, freshly cleaned with water and hardware attached haphazardly. Take a look inside. We've got space for all your favorite albums and junk. And over here, a nice, clean preamplifier unit and turntable with Bluetooth hiding, because we want to think that this is from the 60s and not updated, but we've got these updates here. Let's cut the lights and go over some of our features here. Oh, one more light. We turn this thing on by coming over here to the Timbres switch. There we are. And our dial face lights up. Right now we're in aux, which is how we would use our Bluetooth. We may still be connected and we can take a listen to everyone's favorite song by turning up the loudness. Oh, let's turn up that timbre if we want to hear some treble. Pretty cool. Get a little more bass. Too much treble? Pull it back. I think I like it right around there. Coming over to here, we have FM stereo. Our stereo lamp works. If we turn up, we can tune right here. If we don't like all this noise, we can turn up our squelch sensitivity. And it's kind of like FM muting in a way. Looks like we've got a little too high. I like this one. We've also got regular FM with no stereo. FM AFC, which is something from the 60s. And then we've got the crazy AM. That sounds ridiculous. Our balance potentiometer works. But last but not least, we gotta demonstrate the phono section. I turned the lights back on. I mostly just wanted to see the lamps lit up for the first time. I had never seen them in unit in the light. So let's pull this guy up, move it over. We're gonna try out everyone's favorite album, The World's Greatest Accordion Hits. This thing gets turned on by turning this thing on. And then we just, we let it auto return. Or put the album on. And if we auto return, we can turn that thing right off. Maybe. Yep, that's right. So that is it for this video. Thank you so much for watching. I hope you enjoyed the resurrection, repair of this all-original Magnavox Astrosonic from 1966. Thank you to my subscribers, and thank you to my members who get early access to videos, just like this one. Before we go out of here, I just want to show you some footage from the day we purchased this thing. I didn't think it was good enough to put at the beginning of the video, so I saved it for the end. Check it out. I'll see you in the next one.
So, where are we going?
Going on a date.
Really?
Yeah, I had this really good idea 20 minutes ago, and now we're going on a date.
I don't know, this seems suspicious.
What's suspicious about it?
No, we have a
Why?
location pinned on your phone.
Yeah, it's the date.
It's in the middle of nowhere.
Yeah. Okay, so I was browsing Facebook Marketplace. What's the story on this?
Not much to tell. A guy in Bozeman gave it to me for free for helping him move it out of his old parents' house. They were the first owners of it as far as I know. So I'm the second owner of
You
it.
still want your records?
I took the ones that I really wanted.
Okay.
So if you sort through those and find any gems, you're welcome to take them.
Kenny Rogers. So it's solid state. Not tubes, but you know, that's not gonna stop me.
Pick it up. I'm good on my side.
And then I can set it in here.
Okay.
Just sit down.
Yep. I'm good on my end.
And then bring it like that, and then you can rotate.
So yeah, the side of it.
Are you okay?
Yep. There we go. Oh yeah.
That's it. Look at that. Can you believe that?
Wow.
I think it'll work.
Amazing.
Why buy anything else? Volvo 240 for life.
Let me see if I have anything else I'm trying to get rid of.
Okay.